Alright guys, we're going to do our last section of Unit 11, and this is 11-4 on spheres. The objective is to learn and apply the formula for the volume of the sphere, learn and apply the formula for the surface area of a sphere. Okay, so first let's talk about a sphere. A sphere is the locus of points in space that are fixed distance from a given point called the center. So this is a three-dimensional shape. And inside the sphere is the fixed point called the center. A radius of a sphere connects the center of the sphere to any point on the sphere. Okay, so here's the radius on the inside going to the outside. And the most popular sphere I know is the basketball. So think of a basketball. All right, a hemisphere is half of a sphere. So that would be the green shaded area right here. And then a great circle divides a sphere into two hemispheres. So this right here would divide this sphere into two hemispheres, and that is called a great circle. All right, I think that's it that you need to know on a sphere. The figure shows a hemisphere and a cylinder with a cone removed from its interior. The cross sections have the same area at each and every level, so the volumes are equal. You will prove that with the cross sections have equal areas in exercise 39. So we'll look at that later. The height of the hemisphere is equal to the radius because it's in the center point and the other end point is on the sphere. Okay, let's move on. All right, the volume of a hemisphere is the volume of a cylinder minus the volume of a cone. Okay, so the volume of a cylinder is the area of that base times the height. Okay, and then the volume of the cone, remember, is 1/3 of the base times the height. So what we're doing here is we are simplifying this formula. And when you simplify it down, this is what you get for the volume of a hemisphere. Now remember, a hemisphere is half of a sphere. So to find the volume of a sphere, what you would do is you would double that. And that's where you get, so you would times this by 2, that's where you get the 4/3. So this here is your formula for volume of a sphere. And guys, I don't know why the smartboard is acting that way. All right, so let's move on. All right, so we've already talked about how you get the formula for volume of a sphere, so let's move on and let's apply it. Okay, so find the volume of this sphere. So your formula is 4/3 pi r cubed. Well, the diameter is given, so the radius is half of the diameter. We need to leave our answer in terms of pi. So we have 4/3 pi times 12 cubed. Okay, and when you take 4/3 times 12 cubed, you get 2004 pi inches cubed. Don't forget your inches there. Okay, now we're going to find the diameter of a sphere with the volume that is giving, okay? So let's go ahead and start with our formula. So with this formula, the volume's given, so we can substitute in. And we can find out what the radius is and then double it to find out what the diameter is, okay? So what we need to do is we need to isolate this r cubed. So if this was 4 pi over 3, what we would do is we would multiply by its reciprocal. Okay? So we're going to multiply the right side by its reciprocal, which would be 3 over 4 pi. And we got to do the same over here. So this cancels out. On the right side, we have r cubed. Over here, your pi cancels out. 4, we're going to 36, 9,000 times. So what is that going to be? Okay. Then we've got to find out what r is. All right, and I'll show you in class before you have to do this on how you can find this in your calculator. You're going to use this button right here, okay? So once you find out what the cubic root of 27,000 is, you get 30. We're talking about centimeters, therefore your radius is 30 centimeters. Okay, now we're going to find the volume of the hemisphere. Now remember, the hemisphere formula was 2/3 pi r cubed. Well, your radius is given here, so all we need to do is substitute in. Now, it doesn't tell you whether to leave it in terms of pi or not, so let's be as precise as possible. Leave it in terms of pi. So 2/3 times 15 cubed is going to be 2,250 pi meters cubed. All right, I'll let you read this on your own. And we're going to have to find the volume of the standard and of the jumbo. Okay? All right, so for the standard, it's giving you the diameter. So if the diameter is 22, your radius is 11. Okay, and when you work this out, you're going to get approximately 5,575 cubic inches. Okay, so here's for your standard. Now we need to do the same and find the jumbo. Well, your diameter is given at 34, so your radius is half of that, which is 17. So when you key that in your calculator, you're going to get approximately 20,580 cubic inches. Okay, so we want to know how many times as great is the volume of the jumbo ball as the volume of the standard ball, okay? So you want to take the 20,580 and divide by the 5,575. And we're going to say it's approximately 3.7. So your final answer is jumbo ball, jumbo ball is about 3.7 times greater than the volume I hope you can see this, of the standard. Okay, let me check and see if you can see it. All right. In the figure, the vertex of the pyramid is at the center of the sphere. So you've got this pyramid, looks like a rectangular pyramid. The vertex is at the center of the sphere. The height of the pyramid is